Hi guys, and welcome to this video on the 2016 Calculator Aloud Year 9 Numeracy part of the NAPLAN paper. And I'm recording this so that you can go through and basically find the answers to the questions you're looking for, or the explanation of why the answers as they are. So I'm going to try and do what I can to do the answers in an easy to understand way. So Jared is paid $18 per hour at his job. How much will he be paid for working 6 hours? Effectively, I would want to do 18 times 6. Now, because this is a calculator, I'm going to do all of these on my calculator. 18 times 6, put that into my calculator, gives me $108. And so there is my correct answer. Which of the following is equal to 36? Now, these are floaty numbers, right? Otherwise known as indices. And what you've got to remember is that 2 to the floaty 3 is the same as 2 times 2 times 2. Whereas 2 to the floaty 2 would be 2 times 2. So if we work each of those out first, we would know that that then would be equal to 8, and that there would be equal to 4. Now, knowing that, we can then turn out or sort of work out the rest of the question. So 2 cubed is 8 times 2 squared, which is 4. Is that 36? 8, 16, 32. That can't be the correct answer. 2 cubed, which is we just decided is 8, plus 2 squared is 4, would give me 12. It's not that one. Now, 3 squared is the same as 3 times 3, which is 9, plus 2 times 2, which is 4. Is that 36? No. So chances are this should be my right answer. Well, let's just check. 3 squared is 9, times 2 squared is 4. 9 times 4 is 36. There is my correct answer. So those floaty numbers are really, really important. Yeah, so to the floaty 3 says take that number and times it by itself 3 times. When keeping horses, 1 hectare of land is recommended for every 2 horses. So we have a ratio here, 1 to 2. So that's area and that's horses. How many hectares of land would be needed for 8 horses? Now, because we now have 8 horses, notice I keep these things in columns. And I'm saying, well, how do I get from 2 to 8? Well, because this is a ratio question, we're looking at multiplication. 2 times what gives me 8? It is times by 4. So in which case, what I do to one side in maths, I must do to the other, which gives me 4 as my correct answer. What is the value of that expression? What is this part of the question testing? Oh yes, it is testing BIDMAS. Now if you're saying it's BODMAS, then I'm going to disagree with you until my dying breath. But the point of it is, I, for me, stands for indices or floaty numbers. Now, does this have anything to do with this? Not really. But what it does have is these positives and negatives and negative and negative. Now, why do we put brackets there? Well, the brain is programmed to actually ignore negative signs, believe it or not. Where we put an open bracket, it trips the brain into now seeing that negative sign. So because we've got to remember a positive and a negative are equal to a negative, a positive and negative, and a negative and a positive give me a, try that, I've got that the wrong way around, actually make that a positive, and then I will just scribble that out and make that a negative, right? So when they are the same, you add, when they are different, you subtract. Now, what does that mean? I'm going to rewrite that question because I have a plus and a minus, which becomes a minus. So that question now becomes 5 minus 17, and a negative becomes a positive, plus 4, and now we can read that along the way. 5 minus 17, and again, you can do this on your calculator, and then plus 4 is going to give me the fabulous answer of negative 8. And believe it or not, if you put that whole thing in your calculator, this whole expression here, your calculator would actually return the correct answer as well. So I don't think you have to do this in your head. Lara earned $16.92 per hour working at a store. And again, realize that the space they give you is for your working out. You are absolutely recommended to do working out in the space. But Lara earned $16.92. I'm going to write that down here because I've got a feeling, per hour at a store. Then this week she worked for 12.25 hours. So that's 12.25. She used the money she earned this week to buy concert tickets for herself and her friend. Each concert ticket cost $19.55. What is the maximum number of concert tickets Lara could budget or could have bought? Okay, so first things first, she's earning $16.92 per hour and she's working that many hours. So I'm going to have to do 16.92. I'm going to multiply that by 12.25. Is going to give me $207.27. Now, because I want to find out how many times $19.55 goes into that, I'm going to divide. So 207.27 divided by 19.55, again, have to do this on my calculator, divided by 19.55 gives me, now, the answer on my calculator comes out as 10.602 04604 ... Now, lots of people, the trick of this question is people will get mistaken and go, oh, this is a rounding up question. I'm going to make it 11 because that 0.6 here makes it 11. Well, no, it doesn't. The question is actually asking you to think about the decimals. And in this situation, she can't afford 11 tickets because if we had 11 times $19.55, then that's going to cost her $215.05. Well, we don't have $215. We only have $207, which means actually the trick is she can only purchase 10 tickets. All right, so again, that's about thinking about the question. Tammy left her room at 8:35 in the morning and did not return until 4:45 in the afternoon. How long was Tammy away from her home? A basic sort of time question. Now again, I tend to do this in stages. I always use 12 o'clock AM or PM as some sort of middle ground, as it were. So I know that 12 to 4:45 is 4 hours and 45 minutes. What do we do here? 8:35, 9:35, 10:35, 11:35 gives me 3 hours, and then 35 to the nearest hour will give me 25 minutes. Now, we're going to add those two together. Now, we need to be careful here because the 45 minutes and the 25 minutes actually gives me 70 minutes, 45, 55, 65, 70 minutes. So that's actually going to give me 10 minutes and 1 hour carried over, and 3, 7, 8. So we'd be looking for an answer of 8 hours and 10 minutes. And there we go, 8 hours and 10 minutes. And again, if people get these questions wrong, it's more because they've added together the 25 and the 45. It surprises me the number of people who think there are 100 minutes in an hour. There aren't. There's 60 minutes in an hour. Mike has 4 cups of rice. He uses a half a cup of rice for one recipe and 1 1/4 cups of rice for another recipe. How many cups of rice did Mike have left? All right, so we've got to do 1 1/4 first, added to a half. Now again, how you do that's up to you. I'm going to do 1.25 plus 0.5 on my calculator. That's going to give me 1.75. We want to know how much he had left, so I'm going to have to do 4 minus the 1.75. We've got 4 cups of rice, but we've used 1.75 of it, which gives me 2.25. And again, this comes down to realizing, do you understand that 0.25 stands for a quarter or 2 1/4? Yeah? So again, I can use my calculator for this to do all the hard work, so long as I can convert things like a quarter is equal to 0.25, a half is 0.5, 3/4 is 0.75. Now obviously you're not allowed to take notes in to be able to do this, so you've got to remember much of this. Mason's receipt from an electronics store was torn and part of it was lost. He knew each 10 pack of batteries cost just under $6. Each USB cable cost just under $11. His credit card statement told that he spent $72.40 in electronics store. How much did the flash drive cost? Okay, so we have 2 lots of 10-pack batteries. So we're going to say, roughly speaking, that he's got 2 times 6. We'll see how this goes. Each USB cable cost just under $11. Well, let's say roughly $11. So he's got 4 of those at $11. Add those two together. So 2 times 6 is 12. 4 times 11 is 44. And adding those together gives me $56. So he spent roughly $56 on those items. He spent in total $72.40. If I take away the $56, $72.40, you take away $56, gives me approximately $16.40 is what the flash drive cost, roughly speaking. And again, because $16 here is the closest, that's the one I'm going to choose. Because again, it says it cost just under $6. Well, I'm going to pretend it cost $6 and see what happens to get closer to that point. All right. At a hardware store, 20 kilograms of sand costs $4.50 and 40 kilograms of sand costs $9. Which graph could show the relationship? This is basically plotting coordinates on a graph. A relationship is nothing more than plotting sort of points on graphs and joining them together. So we've got 20 kilos of sand cost $4.50. So I'm going to look at sand along the bottom, and I'm going to look for 20 kilos being approximately $4.50. So what do? I go from 20 kilos up, and this point here is $4.50. So it could be that one, but hold on a moment, don't get tricked. What about this one? 20 costs, that one's roughly $4.50. It could be this one here. 20 costs In that one there, if you go up $6.50, it definitely can't be that one. So I've now got two to choose from. Why do you think they gave me the second piece of information? Well, to find the point. So 40 kilos costs $9. So what we're going to do now is go 40 kilos and find it where it crosses at $9. That again seems to fit. Let's just check this one doesn't. 40 kilos here is $7. It's not that one. And so I would color this one in as my correct answer. James spins the arrow on the wheel to win a prize. The arrow has an equal chance of landing on each section. Now, because each of these sections have the same sort of area, we just count how many there are. 1, 2, 3, 4, 5, 6, 7, 8. So that means the probability of getting each of these little squares is 1/8. Now, again, what do I notice about my answers? They are written in decimals. Oh, so that means I'm going to need to make sure that that's 0.125. And again, if you're not sure, 1 on 8 is the same as 1 divided by 8, which again, I can put into my calculator and get 0.125. So what is the probability that the arrow will land on a computer? Well, we've got 1/8 here, we've got 1/8 here, and we've got 1/8 here. So altogether, we've got 3 lots of 1/8, which is 3/8. And again, how you do that's up to you. You can do 3 times 0.125 or 3 divided by 8 on your calculator. And either way, 3 divided by 8, let's do it on my calculator, it gives me 0.375, and there is my correct answer. So it's important in that situation to know that each probability is the same and what each pie size stands for. A store sold plates for $5 each and mugs for $3 each. Okay, so I'm going to write that down. Plate is $5, and what is it? A mug is $3. Okay, Nathan wrote the equation 5p plus 3m equals 75 to calculate the number of plates and mugs he could buy for exactly $75. How many plates and mugs did Nathan buy for $75? In this situation here, again, it's trial and error. He's got 5 lots of plates and 3 lots of mugs. So in that situation, he says is equal to $75. Now, actually, I'm going to change that. My apologies. 5 is actually the cost and 3 is the cost. P is the number of plates and M is the number of mugs. So what do I do now? Well, I just substitute it in. So here, P is 5 and M is 3. So 5 times 5 plus 3 times 3. Do you reckon that's going to be the right answer? Well, that's going to give me 25 plus 9. Is that going to give me 75? Nope, so it can't be the first one. So I'm just going to rub these out because I don't have enough space. But again, you can do this on your calculator. So if we now do 5 plates, P is 5, M is 12. So 5 times 5, and bearing in mind we've just done a module on sort of substituting into equations. You guys should be guns at this. 3 times 12. Let's work that one out. It's 25 plus 3 12s is 36. Are we going to make 75? Fairly sure that that's not going to make 75, so it's not that one. Again, we keep going. You're going to ask, is there a shorter way of doing this? Sadly not. 5 times 9 plus 3 times 10. Let's do that one. So 5 9s are 45. 3 times 10 is 30. Add those two together gives me 75. It is that one. But I'm also going to check this last one. 15 and 25. 5 times 15 plus 3 times 25. Well, I know that there is 75. That's going to be way more, so it can't be that one. Leo recorded the number of pages he printed over 5 weeks. What is the mean number of pages now? Other than me being mean, as most people think I am because they don't get to know me, it's very hurtful. Mean is the average. And when you work out the average or the mean of something, you add all the data items together and divide by how many there are. So in this situation, you would be doing 17 plus 22 plus 17 plus 24 plus 20. And I'm going to divide that by 5. 1, 2, 3, 4, 5. So 17 plus 22 plus 17 plus 24 plus 20. Now, a word of warning to you guys. Because your CAS calculator is a dumb piece of machinery, you would then press equals, and then you would divide the answer by 5, which is going to give you a value of 20. Now, the reason being is, a lot of you won't realize that if you do that all in one calculation, if you do 17 plus 22 plus 17 plus 24 plus 20 divided by 5, your calculator's only going to divide that number by 5. Your calculator isn't clever enough to realize that you're adding all those numbers together unless you tell it by putting all of that in a set of brackets. Yeah, so in that situation, I think they're trying to test whether you can use a calculator properly. A jam recipe uses 2 cups of sugar for for every 3 cups of fruit. And again, this is a ratio question. So 2 cups of sugar to 3 cups of fruit. And again, notice what I do. I write down my ratio. A cup of tea. Select the correct combination of sugar and fruit for this recipe. Okay. 1/2 cup of sugar to 1/3 of a cup of fruit. Ooh, okay. So how am I going to get to 1/2 cup of sugar? So what we're basically saying is, to be able to do this, how do we get from 2 to 1/2? What would we divide 2 by to get to 1/2? We would divide by 4. So what we do to one side, we have to do the other. So 3 divided by 4 would give me 3/4. Does that match? Does 1/2 cup and 1/3 cup of fruit? Nah. So in that situation, that is not the correct answer. What are we going to try now? So rubbing that out, actually I'll leave this working on because this one's a bit challenging. 1 cup of sugar to 1.5 cups of fruit. Okay, so let's try this one. S to F again, starts as a ratio of 2 to 3. I want 1 cup of sugar. How do I get from there? 2 to 1, I divide by 2. So I have to do the same to the other side. Divide by 2. 3 divided by 2 is 1.5. So 1 cup of sugar to 1.5 cups of fruit. As far as I'm concerned, that one there is the correct answer. But again, let's just check. 1.5 cups of sugar, 2.5 cups of fruit. So S sugar to fruit, 2 to 3. What are we going from to 1.5? So how do I get from 2 to 1.5? Now, believe it or not, this is quite confusing. You actually divide by 2 and then times by 1.5. Ratios is a huge subject that we need to work on. You may already have done it, but what I'm using here is called the unitary method. So if I now do 3 divided by 2, press equals, and times that by 1.5, I'm going to get 2.25, which is actually 2 1/4. That isn't the answer. And again, the last one isn't going to be my right answer. A class is making crystals using sugar, water, and string. Don't know what that means. Each student needs 1/4 liter of sugar water for the experiment. How many milliliters of sugar water does each student need? Okay, so what you need to know is that 1 liter is equal to 1,000 milliliters, right? So 1 liter is equal to 1,000 milliliters. So knowing that, what have we got? We've got 1/4 liter. So we're going to be able to divide that by 4. And that's going to give me 0.25. And again, if I divide that by 5, it gives me 250 milliliters. I'm just checking this on my calculator, but yep, 250. So 250 milliliters. So in this situation, you need to know or be able to remember some of what we call the basic conversions. So 1 liter is equal to 1,000 milliliters. A table below lists the original price and the amount of discount of the same shirt at 4 different shops. Awesome. Which shop has the lowest sale price for the shirt? All right, so we've got to work out percentages and fractions and all sorts of stuff. So when it's a discount of 25%, you want to work out 25% of $20. Now, I know that percent is the same as divide by 100, and I know the word of in maths is a times. So that becomes 25 divided by 100 times 20. Doing that on my calculator, 25 divided by 100 times by 20 gives me $5. So the discount is $5. The original price is 20, so the new price would be 15. Now again, a lot of people know that 25% is 1/4. So if you've got 1/4 of 20, you could have done that 1/4 of 20, and that's the same as 20 divided by 4, which is also 5. A third discount. So what is a third of 24? Well, that's the same as 24 divided by 3. Again, that gives me 8. So my discount is 8. So I'm going to do 24 minus 8. So 24 minus 8 gives me $16. All right, so nope. What about this one? 30% off. Well, that's slightly harder. So again, I'm going to do 30% of, and in this situation, $30, because that's what I'm looking for. So that's 30 divided by 100 times 30. So 30 divided by 100 times by 30 gives me $9. So again, my discount is going to be 9. So that's going to give me 21. Or this one's just a fixed price off, that's going to give me $16 as well. So the table below lists the original price and the amount of discount for the same shirt. Which shop has the lowest sale price? That will give me shop A, because the lowest price there is going to be $15. Ruby designs a rectangular picture for her wall. Inside her rectangle, she adds 3 straight lines as shown. What is the size of angle X? Right, angles in a circle, angles around a point, those all add up to 360 degrees. This here is a right angle, which means that that section there is 90 degrees. I also know that this here is a straight line, and we know that all of these angles on a straight line add up to 180. So that means that this must also be 45 degrees. Now, rubbing out a lot of these construction lines to make it a little bit easier for myself, and just do these again. So that's going to be 45, that's going to be 90. Now, because I've got vertically opposite angles, I know that when I have an X, so angles that cross, those 2 angles there are the same. That means that that is 45 degrees. So what do I need to do? Well, I already know that these angles here all add up to 180 degrees because it's half a circle, which must mean that these angles here all add up to 180 degrees. So I now know that X plus the 45, yep, so again, if I rub out the construction lines here, I know that this angle here is 45. I know that the X and the 45 add to make 180 is equal to 180. So X must be equal to 180 minus 45, 180 minus 45 is 135 degrees. And again, while I think I might be able to do this in my head, it doesn't hurt to use a calculator. The wheel turns 10 times. Approximately how many meters has the bicycle traveled? Now again, this is about circles, and there are 2 formulas you need to know about circles. Circles, the circumference is equal to pi times the diameter, or the circumference is equal to 2 times pi times the radius. Now, believe it or not, the diameter is 2 times the radius. So, but in this situation here, they've given me the diameter. So my circumference, that means the distance that it travels when that wheel spins 1 time, is equal to pi times 617. Now, again, your calculator has a pi button, so I can use the pi button and times it by 670. And that tells me that the circumference is 2104.87 ... Now what that means is that every time my wheel turns, it travels that many millimeters. Again, I've triggered the question because notice all of your answers here are in meters. Now it says the wheel turns 10 times, so I'm now going to do the total distance traveled is equal to that value times 10, which is going to give me 21,048.7 millimeters. Now, how am I going to turn that into meters? Well, I divide by 10 to get it into centimeters, which is going to give me 2104.87 centimeters. And then there are 100 centimeters in a meter, so I'm going to divide that by 100 to give me 21.0487 meters. So we're looking for the one that's closest to 21 meters, which is going to be that one there. All right. So again, knowing the circumference of a circle, really, really important. Which expression is equivalent to this? Now, this is factorization. So factorization is where you take out the most in a set of brackets. And what you'll notice is the questions get slightly harder and harder and harder as you work through this. Now, some of them you're not going to be able to do because we may not have done the work, all right? And that's perfectly acceptable, but it doesn't mean that if you get to question 18 and you can't do it, you stop. It doesn't quite work that way. So which expression is equivalent to that? Now, when you factorize, you take out the most you possibly can from each term. So if you look here, we've got a 3x squared term, a 9x term, and an x cubed term. Now, when you factorize, you take out the numbers first. So you look at it and you go, well, okay, is there a factor or a number that divides into 3, -9, and +1. Now again, when you're going to say +1, where did that come from? Well, any number that's not written, there is a 1 there. So that's actually +1x cubed. Now there isn't a number that goes into 3, 9, and 1, so there's no 3 outside the bracket. So before I even go any further, I know that that answer isn't correct, and that answer can't be correct. Now what I look at is the letters, and I go, well, this is the same as 3xx, this is 9x or -9x, and that's the same as x, x, x. Because remember, x cubed is the same as x times x times x. So now what we say is, well, what's the maximum number of x's we can take outside or factorize? Well, again, this has got 2 x's, that's got 1 x's, that's got 3 x's. So the maximum I can take out is just 1x. So outside of my set of brackets, I'd be writing x, brackets, and close brackets. And I don't need to go any further because we can see here that's got an x cubed. That's no good to me. So by a process of elimination, it's got to be that one there. Now, Venn diagrams describe probabilities, and we love probabilities. Jenny asked 35 people whether they work, go to school, do both, or do neither. Or neither, no, neither. The Venn diagram shows the results. What is the probability that the person randomly selected from the group goes to school and works? Now, when it says school and works, you're looking here for the overlap. So that's the number of people in this section here. That basically, that section there is the people who go to work and school. This number here, this 14, is the number of people who only go to work. This number here, 16, only the number of people who go to school, and those people only go to school. And this one here are the number of people who don't go to school or work. Right, so that makes Venn diagrams sensible in the sense of, so we're looking for this shaded section here, this 3. So what does it say? What is the probability that a person randomly selected from the group goes to school and work? So 3 people go to school and work out of how many people in total? Because probability has to be out of something, and it's normally the total number. And because that's 35, what do we notice? It's a decimal, so I have to do 3 divided by 35 on my calculator. And that gives me 0.0857 ... Which one is that going to be? Rounded to 3 decimal places. So rounded to 3 decimal places, that 7 there changes the 5 into a 6. So we're looking for 0.086, and ka-ching, there is my answer. All right, now we get on to parallel lines, and this is now becoming all about notation. Lines A, B, and C, D are parallel. So when we talk about a line, when we have these 2 letters here, we're actually talking about lines. So when you look at AB, it's talking about that line there, starting at A, finishing at B. Line CD, line CD. Now they're parallel. How do we know they're parallel? Because of this little sign here. That little mark there tells me they're parallel. Oh, this is getting good, yeah? Good. Lines P and Q intersect AB, so PQ is this line here, intersects. Now basically, for those of you who have had me for long enough, will know that I talk about stuff called physics, where you have the F rule, the U rule, the Z rule, and the X rule. Now when you have an F rule, the angles in the corner of the F are the same. When you have a Z rule, the angles in the corner of there are the same. When you have an X rule, the opposite angles are the same. The only one that's slightly different is this. The 2 corner angles add to give you 180 degrees. So because the question here says which pair of angles are equal, they're looking for you to use what I call physics, but other people call interior angles, co-interior angles, alternate angles. So let's have a look. Now again, the notation that D, G, Q, that sign there is basically an angle sign. And when we have 3 letters, it says start at D, go to G, and finished at Q. And it's the angle basically in the middle of those. Now most cases you look at the angle, the letter, but in this you have to have all 3. So angle DGQ and angle DGP. So let's look at angle DGP, which is this angle here. Are they the same? No. They don't look the same, but they do lie on a straight line, which tells me angles on a straight line add up to 180 degrees. That's not the rule we're looking for. So let's look at the next one, CGP. CGP and AFQ. AFQ. Okay, so that's this angle here and that angle there. Again, nope. We know that those 2 angles add up to 180 degrees, but in this situation, they don't look the same size. They're not the same size. Angle QGC, so QGC and QGD, QGD. Again, this angle here and that angle there, no, they're on a straight line. They add to 180 degrees, but they're not the same. And hopefully, by a process of elimination, this should give me the right answer. PGC. So let's see, PGC, yep, and PFA, which gives me this angle here and this angle here. And it just so happens, because you can see an upside down F in this, those 2 angles are the same. And lo and behold, I would colour in that lozenge there, and makes a dot plot to show the ages of students in a dance class. Dot plots are great. They just show information using dots. What is the range of ages? Now, the range in maths is basically equal to the highest number, subtract the smallest number. So we look for a dot that's the highest number, and here is my highest dot, and it sits at 15. I look for my lowest dot, which seems to be at 7, and 15 minus 7 is 8. And so I'm going to colour in my number 8 lozenge. There are 52 people in the conference room. The ratio, again, a ratio, they love ratios here. The ratio of females to males in the room is 15 to 11. Oh, he says writing 15 again. Try that one again. So 15 to 11, and we will write, what is it, males. Oh, sorry, now again, they said females to males. And you have to make sure you write the ratios the right way around. Females to males. How many females need to leave the room? So the ratio of males to females or females to males in the room is 1 to 1. Okay, so the first thing we need to do is find out how many males and females are in the room first. How do we do that? Now, when you do that, that means that these 15 and 11 actually add to 26. Now, what I'm saying is here, 15 females and 11 males give me 26 people. How many people are in the room altogether? There are 52 people. So that's actually twice as many as the ratios. And because that number is twice as many, I can now say that there are 30 females and 22 males in the room. And again, checking, if I add those together, do they give me 52? They do. Now, to have a ratio of 1 to 1, it means I've got to have the same number of females as there are males. How would I go from 30, this is my number here, to 22? I would subtract 8. So 8 females would need to leave the room. A school vegetable garden has 4 lettuce plants, 2 capsicum, 4 times as many spinach as lettuce. Oh, sorry, 2 less capsicum parts of spinach. This is one of those questions. How many plants are growing in the school vegetable garden? Right. So there are 4 lettuce plants. Right, so 4 plants there. Looking next at the lettuce, there are 4 times as many spinach plants as lettuce. So 4 times as many spinach, which gives me 4 fours, which are 16. So there are 16 spinach plants. There are 2 less capsicum than there are spinach. So 16 minus 2 gives me 14. I already love this question. There's 1 parsley, 1 sage, and 1 basil plant. So that's 3. The number of spinach plants is a quarter of the number of tomato plants. The number of spinach plants is a quarter of the number of tomato plants. Okay, how many spinach plants did we say there were? 2 less capsicum plants than spinach plants, 4 times as many spinach plants. There are 16 spinach plants. There are so the number of spinach plants is a quarter of the number of tomato plants. So basically, we're then going to take 16 and multiply it by 4, because that's how many tomato plants there are. There are 64 tomato plants. Just want to check that. For lettuce, there's 4 times as many spinach plants as lettuce plants. Yeah, 16. So 16 lettuce plants. The number of spinach plants is a quarter of the number of tomato plants. Yep, so how many plants are growing altogether? You would then add all those together. 64 plus 3 plus 16 plus 14 plus 4 is equal to 101. And as you can see, these things get progressively more complicated, but it doesn't mean you can't answer questions or give it a good go. A shop sells 4 size cans of kidney beans. Which can of kidney beans costs the least per gram? So they've given you a hint here that it's cost per gram. So when we do cost per gram, the word per actually means divide. So you want to take the cost of each of these and divide it by how many grams there are, right? And this is called unit pricing. So if we look at can 1, we've got $1.76. $1, oh, can't get my calculator to it. $1.76. I'm going to divide that by how many grams there were. 400 grams gives me a what is it? Cost per gram. Yeah, so that's going to give me 0.0044. That's strange. So now we're going to do $1.89. Yeah, so $1.89 divided by 420 grams gives me 0.0045. So we've now got $1 divided by 125 grams, which gives me 0.008. Now I'm going to write that as 80. Why? Because I've got 4 decimal places here, 4 decimal places here. I'm going to try and keep these to 4 decimal places. It's going to make my life a little bit easier to compare. $2.40 divided by 500 gives me 0.0048. Now, because we are looking for the least per gram, and because we've got these all as 4 decimal places, I can read my values as 44, 45, 80, and 48, which will give me can 1 is the least cost per gram, all right? Because that's going to cost 0.0044 per gram, less than half a cent. The sum of the interior angles of a pentagon can be found by first dividing into triangles from one vertex. What is the sum of the interior angles? Well, the reason we split these into triangles is we know that there's 180 degrees in each of these triangles, which means I've got 3 lots of 180 degrees, which gives me 540 degrees. Now, the interior angles are basically all of the angles here in the corners. Yeah, but the easiest way to do that is to basically split any shape. So if I had this shape, for example, I take one corner and connect it to all the other corners I can, and then each of those triangles gives me 180 degrees, 540 degrees. A Cartesian plane is shown. Now again, Cartesian plane, what's that mean? It's basically just a coordinates placed. Let's see what comes up. Cartesian plane is shown, you've got some points on there. State the correct statement below. O is located where x is 0 and y is less than 0. Now basically, this notation here means below the x-axis. So when you have y is less than 0, it basically means all the points here. Not on the line, it doesn't include this x-axis. That x-axis there is not included. So we can't have that in any way, shape or form. But we're looking for point O. Well, does O fall in that region? No, it doesn't. So that's no good to me. That's not the first one. J is located where x is greater than 0 and y is less than 0. Now, again, when x is greater than 0, it's talking about the section over here. So when x is greater than 0 is in that. We've just worked out that when y is less than 0, it's this region here. So is J located there? It would appear not. So that's not my right answer either. So I'm going to ignore that. What about K is located where x is less than 0. So when x is less than 0, it means the right-hand side here. And y is greater than 0. Now y being greater than 0 is here. So is K in that section there? Well, I've scribbled all over it, and yes, it does. Because those two areas overlapped, and again, when I did this here and this, those areas overlapped. That's what we were actually looking for. So K was my correct answer. The Louvre Pyramid in Paris, France is made up of 4 triangles and a square. Roland is hired to clean the interior sides of the floor of the Louvre Pyramid. What is the area that Roland will need to clean? Ooh, dear me, how are we going to work this one out? So 4 triangles and a square. The fact that this is a square helps us out a little bit because we now know that this length here is 35. So we know that that length there is also 35. That's fine. What have we got to do? I need to clean the interior sides and the floor of the Louvre Pyramid. So the floor is, we can already work out the area of the floor here by doing 35 times 35. So that's the square section. Now what we've got to do is try and find the area of one of the triangles. So how do we do that? Well, we want this triangle here. Can we find the area of the triangle? Yes, we can. We know that the area of a triangle is a base times that there, perpendicular height, divided by 2. So we know that this length here is 35. We know the height of this is 28.6. And I'm going to do a half of that because remember the area is a half base times height. So that's just one of the triangles. But how many triangles do I have? I have 4. So I'm going to multiply that by 4 and add those two together. So the base we've decided was 35 times 35, which is 1225. We're going to do 0.5 times 35 times 28.6 times by 4. Put that into my calculator. Gives me 2002. Add those together. Gives me 3227 meters squared. Mike puts $100 into a simple interest account for a year. He does not take any money out or add any money to the interest. At the end of the year, he has that in the account. What is the annual percentage interest rate? Okay, so he's just put it in for a year. Now the interest is how much money you get extra, right? So the annual percentage interest rate is basically the interest divided by the initial amount times by 100. Right, so what interest did he get? Well, he started with 1,000. He ended up with 1,050, so he got $50. Divided that by my initial investment, which was $1,000, and times by 100 to turn it into a percentage. So 50 divided by 1,000 times it by 100 gives me the interest rate of 5%. Seth draws a target as shown. What is the area of the entire target? Okay, how are we going to do this? It's not to scale. So first things first, what is the area of the entire target? Now there's people, this is a bit of a trick. People will try and find out the area of this little bit and the area of this and the area of this. You don't need to. You can actually find the area of the whole target so long as you remember what the area of a circle is. And again, area is equal to pi times the radius squared. So you got to ask yourself the question, what is the radius of that circle? Well, the radius of the circle is the distance from the center to the edge. Do we know that distance? Well, I should, Coco, because we've got 2.5 here, 2.5 here, 2.5 here, 2.5 here, and 2.5 here. They're writing these here to actually trick you. The whole thing here now is just smoke and mirrors. It's all about tricking you. So what do we know the radius is? We've got 1, 2, 3, 4, 5, lots of 2.5. So 2.5 times 5 gives me 12.5. So my radius is 12.5. So therefore my area is equal to pi times my radius of 12.5 squared. Again, you've got a pi button on your calculator. Times it by 12.5 and square it, and out comes, now what does it want? It wants it to the nearest square centimetre. So my calculator is giving me the area is 490.8738. So the nearest centimetre, I'd need to look at that value there, which is an 8, and realise it is going to change this to 491. The box below contains pieces of chocolate. What do we have here? Each piece of chocolate is 75 centimetres in size, or 75 centimetres cubed inside. Now this is a volume, because it's got a floaty 3. What is the maximum number of pieces of chocolate that can fit inside the box? All right, now what they're basically saying here is, we know the length of this is 21 centimetres. And we've got one piece of chocolate, which they've funnily enough given you here, and they've given you the volume. Now, if we could find the length of this little bit there, of one slice of chocolate, I could work out how many of those would fit into 21 centimetres. So basically I've got to find this length here and divide that into 21. So we know the volume of that shape is the area of cross-section times by how far back it goes. So let's call that height in this situation. We'll call that h. Stupid, but that's what we tend to do. Now the area of cross-section is basically the area of that triangle. How do we find the area of a triangle? The area of a triangle is a half of the base measurement, which is 9.9, times the height, which is 8, and times this here. But do I know the volume? I do indeed, it's 75. So I could put that into my calculator using the solve function or whatever, but in this situation I'm going to do 75, I'm going to times it by 2 to get rid of this half. I'm going to divide it. I'm going to divide that by 9.9. I'm going to divide that by 8. And that's going to give me a height or a distance, he says, writing in highlighter, height or a distance of 1.8939 centimetres. All right, so how's that going to help me? Well, now what I need to do is work out, well, how many of those will go into 21? So I can now do 21 divided by 1.8939, blah, 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 blah. So I'm going to do 21 divided by my answer, gives me 11.088. Right, so 11.088, and again, in the previous answer, we'd need to make sure that that then was 11. What is the value of x if 3x on 2 plus 4 equals 2x minus 1? Again, these are the type of questions you should be able to solve, because we're going to get the letters all on one side and the numbers all on the other. And don't worry about the fact there's fractions. So first things first, let's get the x's on the same side. So I'm going to get rid of that by taking away 3x on 2. So I'm going to get 4 is equal to 2x minus 1 minus 3 on 2x, because it was plus on that side. I now want to get rid of this minus 1, so I'm going to add 1 to both sides. So I'm going to get 4 plus 1 is 2x minus 3 on 2x. Well, 4 plus 1 is 5. If you need to, you could use your calculator to do 2 minus 3 on 2, but I'm going to tell you that's a half. And how do we get rid of the half? We divide both sides by a half. And if I do 5 divided by a half, I get 10 as my answer. So x becomes equal to 10. And again, you may find this challenging, but practice, look at it, have a go, come and see me, or your maths teacher. A design is made using twice as many large beads as small beads. The mass of each large bead is 120 milligrams. The mass of each small bead is 80 milligrams. The total mass of all the beads used is 32 kilograms. How many beads are used in total to make the design? Okay, so we know that we've got twice as many large beads as small beads. Now, basically, this is simultaneous equations, way beyond anything we've currently done at Cornish. But let's see what we've got. So we call it L and S. So if we have 2 lots of small beads is equal to the large bead, that's the first one. So 2S is equal to L. We know that 120 large beads plus 80 small is equal to 32,000. Now, why is it 32,000? Because we're dealing in milligrams and grams. So 32 grams to milligrams is 32,000 milligrams. Right, now, in this situation, we would then use our scientific calculators to come up with simultaneous equations. So plus 80y is equal to 32000. And I know that 2y equals x, and I'm going to solve that for x comma y gives me x is how many beads are used in total to make the design. Well, there are 200 of the one beads and there are 100 of the other. Add those together, gives me 300. All right, and ladies and gentlemen, that last question was a little tricky. Now, there are other ways of doing this, in the sense of I can show you now. If you don't know how to use CAS, I'm not even sure you're allowed to use your CAS, but what we would do now is we would substitute. Knowing this equation here, I know that 1L is given by 2 S's. So everywhere I see an L, I can now write 2S. So that becomes 120 times 2S plus 80S equals 32000. So now that becomes 240S plus 80S is 32000. 240 plus 80 is 320S is equal to 32000. Divide both sides by 320 gives you the number of small is 100. And bearing in mind we know that the large is 2 times the small. That would give me 200. And ladies and gentlemen, that is the end of this particular video for the 2016 Year 9 NAPLAN paper. Hopefully you have found that useful. And again, the reason I've done it on video is to allow you to have the opportunity to go back, think about it, come and speak to me or your teacher or however you need to. But again, hopefully you found this useful. Thanks very much for watching, guys. Yes, this is the end of another video. If you haven't already done so, can you click on my subscribe button? Yes, it doesn't mean anything other than the fact that I know that you are watching. Yes, it's greatly appreciated. Otherwise, I feel like I'm sitting here just talking to myself. And then, yes, there is mathsguru.com, of which you can see a still of now. And what is over there? Well, all the videos ordered by textbook, ordered by topic. You can search for the videos. You can download notes, time codes, exam questions, and so much more coming up. Yeah, it's absolutely free to join. So I'm done. Thank you very much. I hope to see you in another video. Give me a shout out to your mates if you can. I just want to make sure that everyone finds maths interesting and easy. All right, take care, guys. See you again. Bye-bye. Stay safe.